She solved problems Einstein couldn't. But they wouldn't let her teach unless a man stood beside her. Her theorems underpin quantum physics and modern cosmology. But history left her name in the margins. Emmy Noether changed the laws of the universe. She fought prejudice, exile, and silence. If we want to understand the universe, we must understand symmetry. Emmy Noether, this is not just about equations. It's about the cost of genius. In a world afraid of it, Emmy Noether was born into a paradox, a mind built for logic, in a world that was anything but logical. The year was 1882. Erlangen, Bavaria, a small university town with rigid rules, especially for girls. Emmy wasn't loud, she wasn't flashy, but even as a child, her silence carried weight. "I never wanted to be a rebel," she once said, "but I was not made to obey either." Her father, Max Noether, was a respected mathematics professor. At night, she'd sneak into his study and pore over the same books his students read. Group theory, algebra, logic. She wasn't supposed to understand. She did. "Mathematics spoke to me," she once told a friend. "Not in words, in structure." But society had other plans. In 19th century Germany, girls were trained in manners, not mathematics. Emmy was expected to marry, raise children, and stay invisible. But she had other plans, too. At age 16, she passed the state teacher's exam for girls, the only formal path open to women. But she didn't want to teach etiquette. She wanted to see the laws that governed the universe. "I do not wish to teach needlework. I wish to teach the structure of mathematical truth." The universities were closed to women, so she studied anyway, in secret, in shadow, in silence. She wasn't admitted to university, not at first. Instead, she audited classes at the University of Erlangen. She could listen, but not speak. She could solve problems, but not ask questions. And still the male students laughed. The professors sighed. A girl doing algebra? It is not the noise of genius that makes it true, she later wrote, but the clarity. And Emmy saw clearly. By the time she was 20, she had memorized entire branches of algebra. And when she spoke, it was with proofs that left even seasoned academics breathless. By 1903, Emmy Noether was finally allowed into university, but not as a student, not as a professor, as a guest in the very field she would one day revolutionize. The University of Göttingen, a temple of mathematics, home to some of the greatest minds of the century, David Hilbert, Felix Klein, Hermann Minkowski. But even here, Emmy had no seat at the table. "She may sit," one administrator reportedly said, "but she must not be heard." She wasn't listed on rosters. She wasn't paid. She couldn't even sign her own name to her lectures. A male professor had to do it for her. "I do not want titles," she once wrote. "I want the freedom to think." So she thought, in hallways, in borrowed offices, in stolen moments after others had gone. Emmy's mind raced through algebra, logic, topology. But her obsession was symmetry. She believed that the laws of physics were hidden inside the structure of mathematics itself. That if we understood symmetry, we could understand the universe. When one studies mathematics, one does not seek truth, she said. One seeks invariance, that which does not change. And slowly, silently, she began to see a pattern no one else saw. While Einstein was developing his theory of relativity, Emmy was creating something just as radical, a proof that symmetry itself creates physical laws, energy, momentum, conservation. All of it, she showed, could be derived from the elegant balance of nature's equations. It would become known, years later, as Noether's theorem, a cornerstone of modern physics. But in Göttingen, she was still invisible. The university refused her a professorship. She could lecture, but only under a man's name. What she taught us, her student remembered, was not only mathematics, but dignity. She didn't fight back with politics. She fought back with clarity, with chalk, proof, and persistence. In 1915, Albert Einstein was stuck. His theory of general relativity, brilliant, beautiful, was missing something. It worked, but it wasn't stable. The math didn't quite hold. The energy didn't quite conserve. Something was slipping through the cracks of space-time. Then a colleague said 5 words that changed everything. You should write to Noether. Emmy Noether, the mathematician no one had heard of. The woman not allowed to teach in her own name. The one working in the shadows of Göttingen. But when Einstein sent her his equations, she saw the flaw and something more. Your equations are not wrong, she told him, but they are incomplete. The laws are hiding in their symmetry. In just a few pages, she wrote what Einstein could not, a mathematical proof showing that every law of conservation in physics emerges from a corresponding symmetry. It was one of the most profound insights in modern science. If a system looks the same today as it does tomorrow, time symmetry, then energy is conserved. If a system doesn't change when shifted in space, spatial symmetry, then momentum is conserved. Her theorem united the deepest principles of nature into a single elegant framework. It is through symmetry, she wrote, that we recognize the essence of reality. Einstein was astonished. He later said, in the judgment of the most competent living mathematicians, Fräulein Noether was the most significant, creative mathematical genius thus far produced since the higher education of women began. But outside the walls of Göttingen, her name wasn't in the newspapers, no awards, no positions, just silence. Even as the foundations of physics were shifting under her feet, Emmy Noether never asked for recognition. She only asked for chalk, a blackboard, and silence to think. But in 1933, even that was taken from her. The Nazis had seized power in Germany, and Emmy, Jewish, female, politically outspoken, was targeted. She was dismissed from Göttingen, her lectures banned, her office emptied. One colleague tried to protest. The university replied, "It is the law now." Mathematics knows no race, no sex, no politics, she wrote. But men do. At 51, Emmy Noether was exiled from her homeland, her name erased from lecture halls she had built with her brilliance. But exile is not the same as silence. Across the ocean, a small women's college in Pennsylvania opened its doors. Bryn Mawr, Noether arrived with one suitcase and an unshakable fire. Her classroom was small, the chalkboards old, but the equations, they were bigger than ever. She brought elegance to abstraction. Her students described her as radiant with thought. The grandeur of mathematics, she told them, is not in complexity, but in its harmony. She worked without fame, without salary. Her lectures were described as chaotic, fast, unstructured, but brilliant. She taught until the very end. On April 14th, 1935, Emmy Noether died from complications after surgery. No newspaper headlines, no obituaries in the journals she once illuminated. But in a quiet room in Princeton, Albert Einstein wrote her eulogy. Noether was a mathematical genius, he said. The most significant woman in the history of mathematics. Emmy Noether didn't live to see her name in lights. But her ideas, they became the light. Decades after her death, physicists began to realize the deeper they looked into the fabric of the universe, the more her symmetry echoed through it. Every field of physics, from quantum mechanics to relativity, from the Higgs boson to black holes, depends on Noether's theorem. Her name is etched into the foundations of the Standard Model: symmetry, invariance, conservation. These weren't just math tricks. They were the fingerprints of the universe. In 2016, when scientists detected gravitational waves for the first time, they used equations rooted in Emmy Noether's ideas. When satellites orbit perfectly, when energy doesn't vanish, when particles behave as expected. We're watching Emmy's math unfold, in silence, in space. The beauty of mathematics, she once said, is not in its answers, but in the laws that remain. She left no children, no fortune, no fame, but she left something more powerful, a mathematical law that will outlive us all. Noether's theorem is now taught in every advanced physics class. Her equation appears in textbooks across the world. And still, most students don't know her name. But maybe they should, because Emmy Noether didn't just understand the rules of the cosmos. She redefined what it meant to be a scientist. Emmy Noether never stood in the spotlight, but she illuminated the world. She broke through a wall that wasn't just made of stone. It was made of silence, of doubt, of erasure. They told her, "Women can't do this. You can listen, but don't speak. You can solve it, but someone else will sign their name." And still, she did it anyway. "We must not let others define our boundaries," she said. "The work itself will prove who we are." Today, Emmy Noether is more than a name in a textbook. She is a symbol of what it means to pursue truth when the world doesn't believe you belong. A reminder that brilliance does not shout, it proves. Her life teaches us that the deepest power in science is not just in discovery, it's in courage. Courage to ask questions no one's ready to answer, to do the work no one will reward, and to believe that even if the world forgets your name, the universe remembers your laws. To understand symmetry, she said, is to see the shape of truth. Emmy Noether saw that shape and left it behind for all of us. If this story moved you, share it. Let her name be heard. Let young minds know. You don't need permission to be brilliant. This was the life, legacy, and lesson of Emmy Noether. Subscribe for more stories that history tried to silence. But science could never forget